I feel like what you're saying is like, Kubernetes is kind of like fine wine, like it takes time to perfect it, right? And, when you start off, like there are so many different tiles that you can use to optimize it.
One of the first questions you should be asking, because I've seen plenty of Kubernetes clusters that, like the idle capacity is 40, 50%, not really used. So it's like grossly oversized, right?
Hello, everyone, and welcome to another episode of Our Tech Chronicles. This is episode 17 and our last episode of season 1. We have a really fun topic for you today. We're going to talk about cost optimization with Kubernetes. Kubernetes and cost management is a critical challenge for so many companies. And to talk about this, we have a very special guest today. We have Rajith Attapattu, a very good friend of mine. In fact, he and I went to school together, so we've known each other for a very long time. He is now the founder and CTO of Randoli, and they specialize in observability and cost management, specifically for Kubernetes clusters. He's spoken at many industry conferences, and published many articles. In fact, he's also the contributor to the book 97 Things Every Programmer Should Know. Rajit, we're honored to have you. Thanks for joining us.
Well, thanks for having me. It's a pleasure to be a part of this. I've been following your podcast episodes and I'm a fan. So it's a privilege to be here. Thank you.
That's awesome. Would you like to tell us a little bit about your company, Randoli?
Absolutely, yeah. So, like you mentioned, we focus on Kubernetes and on the observability space, and we've got two products. One is observability for Kubernetes and cost management for Kubernetes, and both the products work together, so you get like a unified observability view across from performance to cost. And there's a security add-on as well. So very excited. It's an exciting space to be in as well, with Kubernetes now sort of in mainstream adoption phase.
Awesome. Very cool. All right. Before we get started, managing cloud costs is a challenge in any industry, right?
Right.
What's the most ridiculous or surprising over budget moment you've ever encountered, whether in tech or personal or even like on vacation, maybe? Go.
You specifically to Kubernetes, I'm assuming, or
Anything, just generally.
I mean, without naming anything, I guess we've seen a lot of organizations that have GPU based nodes, very large nodes with tons of idle capacity. That's just running. So it's not just a waste in terms of from a cost perspective, but it's also just chewing up electricity and other stuff as well. So there's the energy saving component to it as well. So I think that's like I can't say the numbers about like cost optimization. That's one. And I think the other side of the coin is people having sticker shock at the end of the month. I've heard a couple of horror stories, including one with a friend that you and I also know. I'll probably say afterwards. Suddenly, he had a massive lambda, like a bill, because
Yes.
you know who I'm talking
I
about.
know. Yeah, I know.
Right. But I've heard multiple customer horror stories now that we started to be in the space where you suddenly notice mostly because of programmer error, and suddenly, yeah. I mean, if it's due to business like activity, that's fine, right? I mean, there's some revenue to show for it, but yes. Sorry, I couldn't share specifics and be more
Yeah.
colorful.
That's fine. Sanka, do you have anything?
Nothing specific, but I think my stories also relate to like when people first started using cloud and then leaving jobs running overnight and then finding a sticker shock the next day. And, we learned it the hard way that we have to shut down your jobs.
Yeah, I've gone through the same thing too. Cool. Let's get started.
Excited. Let's do it.
So maybe I can get started with the first question, but before we jump into the details around like the cost and cost optimizations,
Mhm.
maybe Rajit, you can give us an overview of like what Kubernetes is, like how they are constructed, and even highlight like what are some of the use cases that they are mostly used for?
Okay, great question. So I think the simple way to explain Kubernetes is, at least the way it started, was as a container orchestration platform, taking containers and running them at scale. That's kind of like the easy answer for it. But since its sort of humble beginnings, it has grown into this massive ecosystem. If you go to KubeCon, you'll kind of see what I'm talking about. It's grown not just to have the core platform, and there are a large number of projects in and around Kubernetes itself that provides a lot of services on top of Kubernetes. So the way I would explain Kubernetes now is, like 5 years ago, I would say Kubernetes is a container orchestration platform. Now I would say it's actually an ecosystem with where you can run containers at scale, and even standards like Open Telemetry is part of the CNCF Foundation and associated with Kubernetes. I don't know if that's a good answer, but I just kind of want to give like the sort of like not just the technical answer, but like the way Kubernetes have grown beyond the technology and become a bit of an ecosystem. Yeah.
Well, absolutely. Even us at Atlassian, we're going through this journey migrating from our own homegrown PaaS onto Kubernetes purely because we want to be able to move to multi-cloud now, right? And Kubernetes is a great vehicle to do that.
So on that, like, I mean, let me add this, right? As a smaller organization, it would have been very difficult for us to have a multi-cloud presence. So we run on all three clouds right now. And the only way that it is manageable is because we have this common standard Kubernetes, so that we can build sort of like containers give you that immutability and the ability to kind of like run anywhere that a container can be run. But Kubernetes has given us that common sort of orchestration platform that we can easily build and manage our production environments across all these three clouds. Yes, there's the cloud vendor flavor to it, but everything else is the same, right? Like this is the same Helm chart that gets deployed across the same controls and other things. So it's also a bit of a standard, and it's an ecosystem that has facilitated this. Yeah.
Absolutely, yeah.
Yeah, just
All
to add,
right.
I think this multi-cloud journey is becoming more a requirement, especially in Europe. I think they recently passed an act. I forget the exact name of the act, where you can't be locked into a single cloud operator.
Mm.
So multi-cloud is becoming de facto in Europe.
Yeah, you'd find a lot of the banks, even in North America, now beginning to do a multi-cloud strategy, just for that same reason that you talked about as well. Yeah.
Rajit, can you give us a quick overview of the key cost drivers in Kubernetes and maybe what makes cost management in Kubernetes particularly challenging?
Right. So there's so when it comes to the when it comes to cost, if you take a Kubernetes cluster itself, there are sort of like three aspects to it. So one is the overhead of running the clusters, the cluster overhead cost, and then you have the resource allocation costs, and then the resource usage costs. Maybe this might be a good time for me to kind of show a bit of a diagram, and then
Sure.
we can also talk about the three sort of like the three kind of categories of kind of costs that are associated. Is that cool?
That would be awesome. Yes.
Okay, let me do that. Yeah, I think I also do a better job when I when I when I use the diagram. You guys can see my screen.
Yeah, perfect. Yes.
All right, awesome. So if you mentions if you take like a Kubernetes cluster, and then when you look at the cost makeup of that cluster, you have the cluster overhead cost, and this is where your control plane cost, any kind of licensing subscription cost that you have, right? Like for the tools that you use, if you use something like OpenShift, there's a licensing cost for that, and there are other indirect costs like your overhead of running the platform, right? And then you take your sort of like your workloads and sort of like the usage of it, you have the allocation cost. And this is typically your compute, your desk,
Mm.
and other things like load balancers and stuff like that, right? And then you also have the usage cost. This is based on the actual usage of it, the network costs, right? And then that sort of breaks down into the three segments, right? So when you talk about network, you have to pay attention depending on how your cluster is set up. For sure, you'll have egress cost because someone has to use your applications that are running on the cluster, right? So that's egress cost is the cost that's actually exiting your cloud vendor and serving traffic over the internet. Then you have cross zone traffic. That's the best practice or So like the recommended pattern to deploying a high availability Kubernetes cluster is to deploy your cluster across three availability zones so that you can tolerate the outage from a cloud vendor on a particular availability zone, right? But when you do that, though, what they don't really say in the fine print is that traffic between those availability zones is charged to the customer. It's like 1 cent per gigabyte, if I'm not mistaken. Please don't quote me on the pricing. I can't remember off the top of my head, but it's not a some cases it's not a insignificant cost. So recently, I actually did a LinkedIn post where I kind of showed for even one of our test clusters. It was a bit of any cross zone cost because we ran a Kafka cluster that's spread across the three availability zones, and then just the communication internally within the Kafka cluster drove up that cost. So that's the cross zone traffic cost, and then you have cross region where you may be talking to some service within another region within your cloud vendor, and there is a cost to it. And one of the nuances here is that when you look at the cross zone traffic, like the advertised price is, let's say, 1 cent per gigabyte, they charge you going out of the zone and coming into the zone, so you're actually paying double
Mm.
the price that's there. There are some really good articles that people have written about this as well, that I can point to, and maybe when you're posting, I can reference them. But that's something to pay attention. But that's the usage, and then the allocation. Just coming back again, the allocation is when you build up your Kubernetes cluster, you reserve, you get whether it's you know on demand nodes that you actually get at the time it gets allocated either dynamically or statically. So like let's say you can say I want a Kubernetes cluster with 5 nodes, or you can say I want a Kubernetes cluster with between minimum 3 nodes and maximum 10 nodes, right? And it scales that. But as soon as that node gets attached to your cluster, the cost, that's why it's its allocation, because from that moment onwards, whether you use it or not, you're going to get charged for it, right? So that's why it's important to understand it's the difference between the allocation cost and the usage cost.
That's a really good overview, Rajit. That's really helpful.
Oh,
So I'm just curious, like, relative to, traditional infrastructure, how do you compare the Kubernetes cost?
right. So that's another great question. So if you look at the managed Kubernetes offerings, they charge you a control plane cost, and the rest starts around $70 a month. Minor differences between the cloud vendors. The rest of the cost is actually your EC2 cost. So like your regular VM cost, right? So the management, the control plane cost is the only additional bit that you have to pay if you are not, let's say you're just using a bunch of EC2s or whatever the equivalent for AKS and GCP. That's what you're paying, right? Like that's the difference actually. If you look at from let's say a 10 VMs versus a 10 node cluster, the difference is the control plane cost. I mean, of course, there are other things that maybe like the number of load balances you might be different. The disk and other things could be different because of the use case. But in general, I mean, if you look at like doing cost comparison, that's an easy way to think about it. Like the only additional part is the control plane cost. So in
Perfect.
some cases, for me, it's a no-brainer because like there's a lot of benefits that it brings. Yes.
Perfect. Now that we kind of get like how this cost is structured, slightly changing the gears, let's talk about like cost optimization strategies. And maybe to start with, like if you can give us some insight into like how effectively can we right size the pods in Kubernetes? Like how do you determine, like you talk about like base cost, like what's the base resources you need to allocate? So and there are also like different instances like RI versus spot instances. Like how do you combine those to maximize the cost?
Okay. Right. Right. Sure. So when we talk about the cost optimization strategies, perhaps it might be useful to look at a couple of sort of fundamentals. Then I can explain the other stuff better. And then also because you asked, I don't know A very good question about cost optimization. I have one thing that I want to show you, and this is like an industry survey to show why that part is useful. And this is from the 20. I don't have the 2024 one, but this is the 2023 SysDig report from SysDig. The amount of wastage that's out there, and there's a lot of opportunity for kind of cost optimization based on these industry surveys. So coming back to what Asankar asked, we looked at the cost sort of breakdown. There's two other things I kind of want to look at, and then we can talk about the cost optimization strategies. Is that cool? Yeah, right. So before we talk about optimization, we did talk about the breakdown from a cluster perspective. Now, in the cluster itself, if you look at the resource allocation, so resource usage is if there's traffic and you're driving activity, that's how the resource usage cost go. But now allocation cost and the overhead cost, you are paying, based on whatever the so the platform overhead, all of those things are there. Now you take the resource allocation cost, that block, you can break that down into two parts. One is the compute and the storage that is actually actively used by your workloads, and the idle. So it's the first thing to look at when you're thinking about optimization is what's the idle capacity of my cluster? Is that too much? Can I reduce it? So that's one of the first questions you should be asking, because I've seen plenty of Kubernetes clusters that, like the idle capacity is 40-50% not really used. So it's like grossly oversized, right? I mean, you can really have like a 99% sort of usage. You need to use, even with auto scaling, you still need a little bit of a buffer, because there's a time limit that's required to auto scale, right? So for business reasons, to ensure you meet the SLAs for your customers, you need a little bit of idle capacity to quickly, to buffer. But as a general practice, you need to, you know, get visibility into it, because that's one of the first areas where you can reduce. If you can reduce the idle capacity, that means you're directly reducing the cost of your cloud bill. So that's the first part. And then let me talk about the breakup of a container cost. If you take this, container is the smallest sort of unit, right? Like, I mean, you take the pod, but a pod is, or could be one or more containers. So if you look at the container cost makeup, each container will use a certain amount of CPU. Some will use GPU. There's memory, disk, and then you have the usage based cost, because the container could drive that, right? So disregarding the usage based part, you look at the container cost side of it. Now, how efficiently the container use the resources allocated to it, is where you can look at cost optimizations. Because if you, so let me go one step, right? So for example, if you look at in Kubernetes, the fundamentals is like every container, or rather at the pod level, you can say my pod has this is my limits, these are my requests, right? And then you come back here, so there's limits in requests for, not for disk, but for CPU, GPU, memory. You can do that. And now here, the first thing to kind of look at, pay attention to, is compared to requests, how much are you using? So what we find is, a lot of places, this is like the requests are way higher than the usage. Why? Because it's a funny graphic that I have. This, because if I mean, if you're a developer, right? If you ask them how much CPU memory do you want, people err on the side of caution. Like, we've done it too. Like, when we're developers too. Like, I don't want to have no memory problems. And this is a constant battle the platform engineers have. And we currently, like, when we work with our customers on the observability side, and what they're saying is, sometimes we have to show evidence to the developer to say, hey, it's not a CPU problem, it's not a memory problem. There's plenty. The usage is low. Else, because the first thing they'll say if there's a problem is increased memory, or maybe it's a CPU problem. So they will give more than that's required, right? So this is that opportunity, because At the least, you should be closer to your requests, right? And because so the way Kubernetes works is it'll guarantee you the requests, right? If you ask, I want X amount of memory, it will try to the pod will fail to schedule if Kubernetes cannot give you that amount of memory, right? And now, if you have auto scaling, what it'll do is it'll try to scale up to fulfill that request. So the request, if there's a gap between your actual usage and your request, that is directly impacting your cloud costs. And memory is a what you call a non-compressible resource, right? CPU is a compressible resource, so you can oversubscribe on CPU, but you can't do that on memory, right? Memory is a non-compressible resource. So because of that, the cluster has to scale up. And now you have this problem because you're actually requesting more resources from the cluster and you're paying, but your application is not really using it. So that's your first optimization, or rather the second optimization point to sort of look at, because it says it's actively used by your work. So you look at the idle, you have the actively used. Inside that actively used, when it says actively used, is actually what the workloads have actually requested. But how much of that are they utilizing, right? The usage, and that's like a simple calculation. If your use efficiency is less than sort of 100%, maybe time to look at it, right? Yeah.
Ajit, that's pretty cool. I loved the diagrams because it helps us understand this so much better. Staying with this, right? And managing costs. Like, what are the key Kubernetes cost metrics that teams should monitor? And are there tools that provide the best visibility into spending?
Okay, great question. So I'll sort of break it down into two. So what you need to get visibility into is, if you just choose one metric, that would be the efficiency of your usage. Because and you can start with simply using Prometheus, because Prometheus can track your usage, and by running a couple of Prometheus queries, you can just look at that, right? The second thing to look at is how much are you paying for each workload, right?
Mhm.
And then there you can again start with open source tools like OpenCost, which we are part of that open source community. OpenCost can, the OpenCost can integrate with your cloud vendors APIs and pull in the pricing. And it doesn't show you the network cost part, but it will show you how much you're paying for CPU, memory, GPU, with your persistent volume. So with those two, you can actually make some improvements. So when we first, I think more than 2 years ago, when we first started using OpenCost, we saved about 15 to 20% of our bill by going through that exercise. And then we realized this is useful for the customers. And that's when we started to actually add that into our product. So it actually came from us using it first and seeing the value.
Mm.
So that if you're doing nothing else, at the least, check it out in Prometheus. If not, try OpenCost. And the only downside of OpenCost is the fact that it's scoped to a cluster. You don't get the multi-cluster view. That's where the commercial vendors like Randoli or KubeCost come in. And that gives you the ability to, like, let's say you have a lot of clusters, that gives you that multi-cluster view where it aggregates statistics across the board and show it to you. Yes.
Before I have another question to follow up to ask you, Rajit. But before I do, hey, if you guys like content like this, don't forget to hit subscribe and post your questions, okay? Staying with your answer, Rajit, very quickly maybe, how does your cost management tool, Randoli's cost management tool, compare with Open?
Right. So thanks for that question. So OpenCost, great open source tool. So you can think of OpenCost as the engine that actually does the basic efficiency calculation and the cost calculation for the workloads. Like I said, it is missing network cost. and then it's only scoped to like a single cluster. So
Mm-hmm.
what we do as vendors is we aggregate the scrape, like we grab the metrics from each cluster, bring it into a centralized location, and then we build functionality on top of it, right? So once you have these basic metrics, you can give people the visibility to look into a breakdown by, say, namespaces and workloads, etc., which also you can see in OpenCast, but scope to a single cluster. So you have to log into each cluster to do that, right? So the vendor product, you can look at, like, single pane of glass. You can quickly select a cluster and look into that. Then you can build additional things on top of that, right? For example, we use some of the data from there, and using some of the other solutions, we provide right sizing suggestions. So you can do, hey, this is your usage and your efficiency, but so I mean, you've given this much, but this is your actual usage. Consider right sizing it to something more appropriate, so you can save cost. You can also do things like cost alerts, like build on top of that. You could, we built a chargeback model on top of it, right? And you can provide a lot of cost analytics. Like, for example, we are trying to partner with one of the and they were interested in figuring out one of these vendors. They run a service mesh, and they want to see what's the cost of running sidecar containers. Now, because you have the data, you can slice and dice it, right? Like, group by label. So there's a lot of other things that you can do once you start collecting the basic cost metric. So you can think about open cost as the like the engine that does the fundamental calculations, and then the vendor product actually grabs everything and then does the analytics and provides the single pane of glass across multiple Kubernetes clusters.
I like that. Thank you.
Really cool. Rajit, you gave a really convincing thesis, right? Now we want to kind of shift the gears again. Can you share some real world examples where this was applied and what kind of steps you took so someone listening to this can really pragmatic perspective?
Right. To answer that, I apologize because you asked a really good question about what are the cost optimization strategies. I think I somehow forgot to answer that, and then actually I will bridge. I mean, I will you bridge from there into the second question you asked. So the different cost optimization strategies. So one is the lack of visibility is hurting. So you need to build visibility. So at the least, get some visibility into efficiency and the cost breakdown, because you can optimize what you don't.
Rajit, do you want to stop the sharing so we can see you? Yeah.
Let me stop the sharing. Yeah. So you can, there you go, better, right? So you can optimize what you don't see, right? So the first thing is to gain that visibility from an optimization perspective. The second strategy is having right sizing guidelines. I mean, a lot of organizations have t-shirt sizing, and the problem with that is, well, it's better than nothing, first of all. But
Yeah.
the problem with that is when people set it, they rarely revisit. So if there's any inefficiencies, there's no feedback loop, right? So if you have right sizing guidelines, if you couple that with the visibility, then there's a bit of a feedback loop. And then it gives the developers and the platform teams a way to right size your workloads, right? So that's the sort of like the second. The third one is in terms of doing things like idle workload detection, where, sometimes this mostly happens in large organizations. So, platform engineering is very popular these days. The problem with that is, now you can quickly deploy on your own. In some organizations, they have made it easy. People can even spin up a Kubernetes cluster. Some people can, get their own namespace. They can do whatever they want. The problem with that is sometimes people do it, they're not accountable, and they forget it. So the platform engineering teams needs a way to figure out, what are the dormant workloads that are just, abandoned workloads that are hanging there. How can we detect that, right? So some kind of strategy like that, right? There are other strategies like, trying to control a little bit more by using things like resource quotas and limit ranges. The idea being that, like you can use, but be a good citizen. You have a bit of a sandbar, sorry, a bit of a fence around your from a resource perspective, right? So you're limited to that. So you can, platform teams can enforce these quotas. And the final one is chargeback. I think, people are more people start to pay more attention when you have to pay the bill. So in larger organizations, they always had chargeback, right? Like, I mean, before, if you ask how much CPU memory, as much as can. But if you send them the bill back, like internal
Yeah.
chargeback, then they're like, oh, wait a minute, what do I need to do to reduce this, right? So chargeback is very important, I think. So that's like the sort of like the other strategy to hold people accountable. And with these strategies, you can try to rein in the sort of like the spending, right? And there are some other specific things you could do. Like, I mean, if you like, for example, when you look at, I talked about right sizing. Just if we speak a little bit more about that. So right sizing, there's two levels of right sizing. You have the cluster level right sizing, then you have the workload level right sizing. So in the cluster level right sizing, a lot depends on the number of nodes, the type of nodes. Like you have, so I think Asanka talked about this, right? Like different classes of nodes. There are memory optimized nodes, there are CPU optimized nodes, there are nodes with GPUs, there are balanced sort of VMs. Then how big or small your VMs you want to do, right? And there are also, you have to balance that with non cost considerations as well. So for example, if you, let's say you have a certain amount of capacity, you can run 3 large nodes or 8 smaller nodes. There's a cost component to it, but there's also a performance and high availability component to it. The less number of nodes you have, and if your nodes are larger, your blast radius is higher, right? Because you may have more containers in that. So if a node goes out, there's bigger impact from a high availability perspective.
Mm.
But the less number of hosts you have, it might reduce your licensing costs.
Mm.
Because some vendors charge based on per host, right?
Host.
Others charge based on per vCPU. But if you're on a node based, so those things, all of those things matter. And then sometimes when you auto scale, you find things like, if it is larger nodes, the last node is always a little underutilized. And that's where that carpenter thing came in, because now it uses variable nodes, and it tries to figure out what's the most optimum node size so I can do better bin packing, right?
Mm.
And then the other thing to think about is, I don't know how we're doing for time, but I'll quickly mention this is spot versus on demand. Like, think
Mm.
about the type of
Mm.
workloads you're running, because that can have a substantial cost saving part to it. Also, the region. Some cloud vendors, like, if you shop around, and maybe you may have the production environments, you have to have it in certain regions for compliance and other things. Maybe your dev environments don't need to. So look for but you have to balance that with like the proximity to your teams
Yeah.
and stuff like that, right? Yeah. So I mean, those are the things. Like spot instances has a huge impact on your cloud bill, especially if you're a startup and if you don't mind the disruption. Even in production, though, spot instance really, like, you can use that for workloads that can handle this kind of disruption, and
Mm.
it's a great way to save on cost here. Sorry, it's a bit of a ramble.
No, no, this is perfect because this is amazing actually. One of the things we wanted to cover was like best practices, and you nailed it. So that's
Okay.
awesome. Maybe Rajit, we follow up on Sanka's question about some real world stories.
Yes, yeah. So I'll start with us. Like I said, when we gained that visibility, we saved about I think anywhere between 15 to 20%. That was one, and then some of our customers, we can't name the names, but we find out that this particular customer has the way they do it is they have 100 namespaces and they time share between the teams, very large organization. And then the problem with that is sometimes some people forget to clean up things, so that
Yeah.
idle workload thing comes into play. We've looked into chargeback models where making people accountable has improved cost awareness. So the ability to spin up clusters or spin up your workloads, but you're also responsible for saving that, right? So things like that. What else? Right sizing is always something that we find, I think, almost any organization, people like without that constant feedback loop, it's hard to know, because as your application grows, as your business grows, so does your requirements, your also change. So
Mm.
what may have worked today may not work. And as you like, sometimes it's also good to monitor from a performance perspective as well, because it's one thing to, so when you say right size, it's not always about reducing the usage. In some cases it's about adjusting so your workloads don't get killed and and having issues. When I talked about right sizing, I actually forgot. I talked about cluster right sizing. Again, I forgot to mention about workload right sizing. Because in workload right sizing, there's also two parts. One is the pod right sizing I talked about, how much CPU memory you need to give. And then the other one is the container right sizing, and the other one is the pod, like, the number of replicas for the workload, right? That also matters because when you scale up and down, right? So using things like CADA or horizontal pod auto scaling, instead of having like a static pool, it helps you scale up and down, so you have a balance between cost and performance. I think a lot of customers that are very performance intensive, they really benefit from this, especially with CADA, because now you can scale instead of people guessing. They can scale based on actual load. So, for example, let's say you're a ride sharing company, right? And I mean, like there'll be surges during like traffic or other events, and everything changes during that time. So you could never go with a static set of right sizing, right? Like, so you need to figure out by using metrics. So CADA will give you, like, you can look at the number of it has a lot of scalars, but I like common things like looking at your number of HTTP requests. You can look at how many messages are backing up in your Kafka topic, and using those metrics, you can scale in a more methodical way, right? And you can take a step further too, like, where you can predictively scale, because for some, that's one of the things that we're experimenting that right now and hoping to release soon. This is a problem where, for example, defined traffic patterns, and reactive scaling is difficult because it takes some time. So by the time your cluster scales and your workload scales, you may have missed some transactions. But if you know the
Yep.
pattern beforehand, then you can, based on machine learning models and stuff like that, then you can scale, like, say, a couple of minutes before or 10 minutes before. Now you're ready to handle the traffic, right? So there's a lot of these variables that come into play. So cost alone is, like, I would say, you can just look at cost and optimize it on its own. There's performance, there's the business requirements. You have to look at all of those angles, and then think about cost optimization from a more holistic point of view, right? I don't know if I talked about all the use cases that Asanka had in mind, but um, yeah,
This is
feel
great.
free to ask more questions. I'm happy to answer.
This is great. I mean, for me, like, I feel like what you're saying is like, Kubernetes is kind of like fine wine. Like, it takes time to perfect it, right? And, when you start off, like, there are so many different dials that you can use to optimize it. And you can't basically manage what you don't measure and monitor, right? So I think that's the key. So you have to observe it. You have to, observe the traffic patterns, utilizations, and, figure out over a period of time, how do you, gradually bring the cost down and optimize in a way that do the trade-off between cost and the performance.
100%. And I think, like, I mean, those days when you used to do this, for a while, I used to work on like performance optimization when I was at Red Hat. Premature optimization is probably the worst thing you can do. So you need that, like you said, you can set it right. Like, you can optimize what you don't see. You need that visibility for sure. 100%.
Rajit, maybe one last thing is, so you mentioned premature optimization. Are there other anti-patterns you've seen that companies make, like common mistakes that don't lead to unnecessary expenses actually sometimes?
I think, especially with, I think, when you enable, it's a good thing, because it used to be that the developers have to wait for certain things to happen. But if you provide those enablement things, you have to have the guardrails. Otherwise, you will come up with expensive mistakes, right? So, couple of things to look at is, you need to have cost alerts, at least at the cloud vendor level, because then you can at least try to get some notification if something is
Yeah.
going wrong. But I think there are other things that you can do, like, for example, enforcing resource quotas, and things like that, so that prevents from, like, we had a minor, like, someone was experimenting with CADA, and it scaled to 100 pods. But because we had other guardrails, it didn't go beyond the 30 pod limit. I mean, you see what I mean? Like, so that there are things that you could do to prevent these
Prevent.
kind of things. It's great. Like, I think we should enable, like, I am in that camp. We need to enable developers to do more instead of, having tons of red tape, but have the guardrails, have the visibility, that feedback loop. make people accountable by, not necessarily just chargebacks. Like smaller organizations too, there's
Yeah.
probably no need to do chargebacks, but people need to see like this is the impact of my actions, right? And then people become a lot more, aware because that
Responsible.
awareness is
Mm.
there. Yeah.
Cool. That was awesome, Rajit. I mean, I think we just only scratched the surface, really. But thank you for taking us through the journey and sharing with us all the nuances about, managing costs around Kubernetes and the dials that you have that you can use based on your different workloads. Amazing.
Oh, thank you. I had fun chatting with you guys.
Amazing. Shall we wrap it up there,
Yes.
Asanka?
Yeah, let's do it. I mean, usually we give a summary at the end, but this is a lot to unpack. At very high level, we gave an overview of how the Kubernetes are structured. We dived into what drives the cost, and then we spoke about how to effectively right size the pods, and then discuss about the trade-offs between performance and optimizing the clusters. And then we spoke about some aspects around how open cost versus Randoli cost management system work. And then we spoke about some real life examples amongst many other details that I didn't recap. But amazing session, I learned a lot. I'm definitely going to take some screenshot of those screens that you shared with your permission.
Yes, yeah. I can send them over to you as well. Yeah.
And
Thank you.
all of you, if you're running Kubernetes, I urge you to check out Randoli's cost management system. Keep your costs in check, right? And Rajit is always there, and his team is there to help you. We might do the same too. With that said, hey, thank you for this. This is a really good way to wrap up season one. We'll see you all in season two in about a month's time.
Thanks for having me. I really appreciate it. And I had a lot of fun speaking about.
Our pleasure, Rajit.
Yes,
Thank you.
take care. Bye bye.
Okay.